Today we're going to talk about a special thing called trigonometric ratios. Now, trigonometric ratios are always going to deal with right triangles. Now, here is what a right triangle looks like. A right triangle looks like something like this. Now, the key is, for trigonometry, what we're doing is we are relating the angle, one of the angles, with the sides. So imagine if I have an angle here, okay? Now, this right triangle here, based on the legs, so which are here and here, are what we call opposite and adjacent to the side. Now, the only side that we know for sure that doesn't really have much to do with the angles is this thing here. If I look directly out from the right side, from the right corner of the triangle, this thing over here, we call this the hypotenuse. We're going to call it H. All right. And you need to remember that this is always the longest side in the triangle. And that side is always going to be directly across from the right angle in our triangle. Now, you'll notice how I highlighted the red and green sides. Those are important sides, right? So in this concept, you need to realize that there are two other sides in the triangle other than the hypotenuse H. We call the side, the green side that is directly beside the angle here, this side, we call this adjacent because it is beside. A for adjacent. And now this other side here that looks directly across, so the leftover side directly across from that angle is what we call the O, also known as the opposite. Okay. Now, sometimes you have triangles that are in different orientations like this, okay? So if my angle is in the top corner, right, we can still use the concept that our hypotenuse is directly across from the right corner of our triangle. We're going to call that H, right? Now, we still have to figure out what our adjacent is. So for our adjacent, what we're going to do is we look for the side that's not the hypotenuse. That's not the hypotenuse, but is directly beside it. And we're going to call that what we used to call it before when the orientation was different. This is the A adjacent. Side. And then this side here, going from here to here, is going to be called the opposite. And because we hate writing so much, we're going to call that O for opposite. Okay? And now, let's talk about the three primary trigonometric ratios that deal with trigonometry. Now, there are three basic trigonometric ratios. Okay? Now, the three trigonometric ratios are sine is O over H, cosine is A over H, and tangent is O over H. Now, we use this special word, meaning so is really means sine is opposite over H. Ka means cosine is adjacent over H, and to means tan is opposite over H. Now, we'll eventually talk about what this means later, but for today, we're going to start by studying some key ideas in how to use our calculators. All right, so now what we're going to do is we're going to use graphical calculators to help us do this mathematics. Now, you're going to use your calculators by either using Desmos.com scientific calculators, or you're going to go and use your own calculator. Now, for your own calculator, you need to have the sine, cos, or tan function on your calculator. Okay? Now, when you're finding a trig ratio, we're going to use these specific functions, sine, cos, or tan, on our calculator. Now, if you don't have a scientific calculator, what I want you to do is I want you to go to Google, and I want you to look for Desmos, right? Type it in. And what we're going to do is we're going to go to the first link called Desmos, and then I want you to go to Math Tools, and then Scientific Calculator. Now, in the Scientific Calculator, we have the main stuff, which has our numbers, but if you click on this section here called Functions, we have all that sine, cos, and tan stuff that we studied before. Now, in order to get to sine, cos, or tan of 30, 75, or 85, what we have to do is we have to literally just do this. Ready? If I want to do sine of 30 on your regular calculator, right? All you got to do is hit sine and then type 30 on your calculator. And notice it gives you 0.5. Now, I'm telling you here that you got to compute this to 5 decimal places, right? So, sorry, to 4 decimal places. So if you have 0.5, what we're going to do is we're literally just going to make sure that we add 3 more spots to it to make it 4 decimal places. So now, let's go and compute cosine of 75. So now, if I want to do cosine of 75, all I got to do is, well, I'm just going to clear this. I'm going to hit cosine of 75, and then, boom, there is my answer. Notice, I need to get to 4 decimal places, so I'm going to have 0.2, 0.02588, and because there is a 1 beside that 8, I'm not going to have to increase my number. Increase my number by rounding properly. So there's my answer, 0.2588. So now, let's say I wanted the tan of 85 degrees. Well, you guessed it. All we're going to do is we're going to go tan of 85. And you'll notice tan of 85 gives us 11.43000 and a 5. Now, you notice how there's 4 decimal places, right? But there was a 5 directly after it, right? Now, because we have that 5 directly after it, after that 4th digit, we have to rewrite this as 11.4300 instead of 0. This specific number here goes up from 0 to a 1. And we're done. That's it. Alright, so this time, imagine that we're going to use our calculators, but this time we have an equation that looks like this. Cosine Q is equal to 0.6921. Now remember, the cosine, the sine, and the tan were all set up as ratios, right? So if I know an angle, I can get the ratio, which is a fraction, which really means it's a decimal. So this is saying, hey, tell me what the angle is that gives me 0.6921. So here's what we're going to do. You're going to open up Desmos, or you're going to use your calculator, right? So for Desmos, here's what you do. In order to get this, you first have to, on your piece of paper, I want you to write Q is equal to cosine inverse of this thing. Now, all that's telling us is that it's saying, hey, undo that little decimal and tell me what the degree is that gives me 0.621. So in order to do that on your calculator, all you're going to do is do this. Ready? All right. So now all we're going to do is we're going to go, all right, function, and then we're going to see in our function in Desmos, like we looked at before. If you don't remember how to do that, go to the previous section and take a look at it. So remember, it's go to Desmos, then go to scientific, and then you're in here. So then you click functions, and you'll notice under sine, cosine, tan, we have sine inverse, cosine inverse, and tan inverse. So this goes and gives us, these ones will give us the angle back. So now, if I want my angle back, this is all I got to do. All right. I'm going to go and punch in cosine inverse. Now, remember, in order to get rid of that, I had to say cosine inverse. So that's telling me, give me the angle back. So on my calculator, I got to look for cosine inverse sign. So I hit cosine inverse, and I go 0.6921. And cosine inverse tells me that the angle of that ratio or decimal gives me an angle of 46 degrees. And writing that out, you're just going to say Q is 46 degrees. So anytime you see these kinds of problems, that's what you're doing. Okay? So just a quick recap. So when we start off with cosine Q is equal to 0.6921, we're going to write Q is equal to cosine inverse of this. So that's telling me is that you're going to say, hey, cosine, give me the angle that gives me that decimal. And when you punch it into the calculator, you're literally just going to do cosine inverse and then whatever the decimal is on the right side, 6921, and it gives you this degrees. Now, you'll notice that I'm only doing the whole numbers. So if it says 46.2, the rounding is 46. So we're going to say it's 46 degrees and we're done. All right. Have a good day. You can work on the problems that I've posted for you. So basically what we're going to do is we're going to do exactly what we did in the previous lesson where we said Q is equal to cosine inverse of this. And in order to punch that in our calculator, we got to follow this example that I have here. So let's say that you have a scientific calculator that looks like this. You notice how I have the sine, cosine, tan buttons that we talked about before. Okay? In Desmos, you'll have it on your calculator that looks something similar to this. Now, let's say that I want to do the cosine inverse of 0.6921. Here's what you do. You hit shift, cosine, and then you put 0.6921, and then you hit equals. And you'll notice my answer is 46.2, exactly like we saw online when we looked at the previous lesson.